Hey, this is the last review of the year, our Unit 10 review. Okay, this is going to take a little while, so I'm going to break this up into a few different videos. Number one, so this is an inequality, and so I have to be careful when I'm solving logarithms that involve inequalities. So when we have a log on each side of the inequality, that's when we have to do that number line business. Okay, so the initial setup's pretty easy. As long as these both say log base 2, as long as their bases are the same, then we just take this expression, 7x minus 3, drop down the inequality sign, and then write down this expression, x plus 12. And then we just solve this like we would solve a regular equation. We need to get our x's on the same side. So I'm going to move the smaller x by subtracting it. And then 7x minus x makes 6x. I'm going to drop the minus 3. I'm going to drop the inequality symbol. That zeroes out, and I'm going to drop the 12. Okay, next I'm going to move the minus 3 to the other side. So I'm going to add 3. When I do that, that zeroes out, the 6x drops, the inequality drops, and 12 plus 3 is 15. And then to undo multiplication, I divide. So I divide both sides by 6. And if I would have divided by a negative, this inequality sign would flip, but I didn't, so the inequality sign stays the same. And then I can reduce this. I can divide both of those by 3. So if I divide both of these numbers by 3, I get 5 halves. Okay, so I know that this answer is over here. And sometimes the answer we get from solving this is the answer, but sometimes it's not. So we have to check it with our number line. So whatever is after the base, it's never allowed to be 0 or negative. This expression has to be greater than 0. And so I can't plug in every number that's greater than or equal to 5 halves into this to check it to see if that makes something greater than 0. So I do this in a slightly different way. So I take this expression and I set it so where it has to be greater than 0. And then I'm also going to take this expression and set it where it has to be greater than 0. So whatever is after the base is never allowed to be 0 or negative. It always has to be bigger than 0. So I set both of these expressions greater than 0 and I solve these equations. So for this equation, first I would add the 3, which makes 7x greater than 3. And then I would divide by 7, which makes x greater than 3 over 7. Because I'm dividing by 7, so you need that 7 in the denominator. Okay, next to solve this equation, I would subtract 12, and that makes x greater than negative 12. Okay, so now I need a graph. So I'm looking at all my answers I just got. A 5 halves, a 3/7, and a negative 12. And I need to put the smallest number on the number line first. So the smallest of these numbers, of course, is negative 12 because a negative is smaller than positive numbers. And then if you don't know what's smaller, 3/7 or 5 halves, you could always put those in the calculator. So I could put 3 divided by 7 in my calculator and 5 divided by 2 in my calculator if I didn't know which one was smaller. But clearly 3/7 is smaller. And then 5 halves is the biggest. Okay, and so then I draw the solutions out for each of these pieces. All right, so I'm going to start with the smaller one. So x greater than negative 12. So we would have an open circle at the negative 12, and we would shade everything to the right. And then x greater than 3/7, we would have an open circle at 3/7 and shade everything to the right. And then this one, we would have a closed circle at 5/2 and shade everything to the right. Well, the solution is where all the graphs overlap. And all the graphs overlap from 5/2 to the right. So that means every number greater than or equal to 5/2 is the solution, which is what answer choice D is saying. So it ended up being the answer we got when we solved the original equation, but that's not always what happens. Sometimes you get all three graphs to overlap in the middle. So sometimes they would, overlap in here, and then I would say that the x was between 3/7 and 5/2. It could be where it's shaded to the left. So you have to check and see where all three graphs overlap, because it's not always that first answer that you get. Okay, that problem's a little bit of a bugger, I'm not gonna lie. All right, next one. This tells us to solve. All right, so whenever you see the variable as an exponent, we have to take the log of both sides to get that exponent down. Okay, so whenever the variable is an exponent, we have to log both sides to get it to drop down. Okay, I'm going to do this on a separate piece of paper because this problem takes a little bit. All right, so I'm going to take the log of the first side, 9 raised to the 2n, and then I'm going to take the log of the second side, which is 40 raised to the 4n minus 7. Okay, now that I've taken the log of both sides, these exponents are allowed to drop down in front. So on the left side, the 2n is in front, and log 9 is in the back. And the other one, the 4n minus 7, is in front. And I'm putting it in parentheses because there's two terms here versus the 2n only had one term. And then the log 40 drops behind it. Okay, what makes this problem complicated is the fact that we have an n on the left and an n on the right. So because we have variables on both sides, this problem requires a decent amount of work. So we need to distribute on the right-hand side to start our process. So we take 4n times the log of 40. And then we take the negative 7 times the log of 40. So the right-hand side, we're distributing 4n times log of 40 and negative 7 times log of 40. And then the left-hand side just drops down. Okay, because I have n's on opposite sides, I need to get them on the same side. Like up here, I had to get the x's on the same side. So I'm going to do the same thing in this problem. So since this n is by himself, I'm going to move this guy over. So to move him over there, since he's a positive 4n, I'm going to subtract him. So this comes down, and I'm subtracting this positive 4n to the other side. So I'm subtracting 4n log 40. And so now that I have subtracted it from this side, he's not here anymore. That just is gone. And all you're left with is negative 7 log of 40. Okay. So because I have two n's and I can't combine like terms, I have to factor out the GCF. And the GCF is the n. So that's one of our major factoring rules. Always look for a GCF. And those have a GCF of an n. So I'm going to take the n out of both of them. So that would just leave me 2 log 9 minus 4 log 40. And then the right side comes down. Okay, we're in the home stretch now. So to get n by itself, which is our goal because we're trying to solve for n, we need to get rid of all of this. Well, because they're smushed together, they're multiplied. So to get rid of multiplication, we divide. So I'm dividing by all of this that's smushed with the m. So I'm dividing both sides by 2 log 9 minus 4 log 40. And I have to do that to both sides. So divide by 2 log 9 minus 4 log of 40. So on the left side, anything divided by itself is 1. So those just cancel out. So all I'm left with is n. Yay, that's what I wanted. And then the right-hand side goes in the calculator. Okay, so I'm going to push alpha y equals to pop up my fraction. It's going to be the easiest way to do this. So alpha y equals, hit enter. So up top, I've got -7. Here's my log button. So log of 40, close the parenthesis, arrow down. In the bottom, I've got 2 log of 9 minus 4 log of 40. So I just get to put this whole bad boy into the calculator. Just have to be careful. And then I hit enter. And we're pretty much rounding everything to 4 decimal places. So we get n is approximately 2.4922. This 2 right here is the 4th number after the decimal, and when I look behind him, it's not a 5 or higher, so the 2 stays a 2. If this had been a 5 or higher behind it, it would round up to a 3. But it didn't. So that's our answer, which happens to be answer choice A. Now, in my opinion, I think we've just done the hardest problem on the entire review, which will be the hardest problem on the test. And I don't know that any of it is too hard, it's just there's a lot of steps. So whenever you see a variable as an exponent, you have to take the log of both sides to get it to drop down. And then if you see the same variable on opposite sides, you're going to end up having to distribute. And then you'll have to move one of those variables over to the other side by either adding it or subtracting it. And more likely than not, you will be subtracting it. And then once you get the variables on the same side, you have to factor out that variable. And then from there, you just divide. Okay, a lot of solving equation skills that you know how to do. All right, this next one is basically the same, but slightly easier. And I'll explain why in a second. So you can see the variable is the exponent, just like up here, the variable was the exponent. So whenever the variable is the exponent, I have to take the log of both sides to get it to drop down. So I'm going to take the log of the left side, and I'm going to take the log of the right side. Okay, so once you take the log of both sides, that exponent can drop down in front. So this 5x minus 1 is going to drop down in front, and I just put it in parentheses because it's more than one term. And then log of 3 is all that's left. I drop down my inequality symbol, and I drop down my log of 30. Ooh, I wasn't supposed to have that inequality sign there. Sorry about that. I was just taking the log of that side. So log of 30. Okay, now the last problem we distributed. But this problem, I'm not actually going to distribute. I could distribute if I wanted. I could take 5x times this and -1 times this, which is perfectly fine. So if some of you wanted to do that, you could definitely do that. The reason I'm not going to distribute on this problem is because I don't have x's on both sides, and I think there's an easier way. So in this last problem, because I had the same variable on both sides, I definitely distributed to get rid of those parentheses. But I also know that another way to solve is to get rid of log of 3 by dividing. Since log of 3 is smushed with the 5x minus 1, they're multiplied. So to undo multiplication, I can divide. So I'm going to divide both sides by log of 3. And then that way, anything divided by itself is 1. So the log 3's just go away. And all I'm left with is 5x minus 1 on the left. Drop my inequality sign. And the right-hand side, I can put in the calculator. Okay, so I am going to do alpha y equals again. So alpha y equals, hit my enter. So remember, here's our log button to the left of the 7. So log of 30 divided by log of 3. Now, I'm just going to write A and S for answer. I get this answer, but I don't feel like rounding it. So I'm just going to keep it stored in my calculator. What would be the next thing you would do to solve for x? You would add 1 to both sides. Okay, so let's do that. Let's just go plus 1. So in my calculator, I'm just going to go plus 1. And it adds 1 to the last thing I had in there. Okay, so then my 5x is going to drop down. My symbol's going to drop down. And I'm not going to write that answer either. I'm just going to put A and S for I've got this answer. And what would the last step be? Divide by 5. To undo multiplication, we divide. So in my calculator, I'm just going to hit divide by 5. So divide by 5. And I didn't divide by a negative, so I don't need to flip my symbol. And I'm going to round to 4 decimal places. So 0.819. Now this time, I have a 5 or higher behind my fourth number, so that 1 goes up to a 2. So if you have a 5 or higher behind your fourth number, then it rounds up. And if it's 4 or less, it stays the same. And so this is my answer, which happens to be answer choice B on the paper. Okay, so there's that problem. All right, number 4. Okay, I think these are fairly easy. So whenever you have these words, compounded continuously, this is the formula we're going to use. And this formula will be provided for you on the test as well, so it's not something you have to remember. Okay, so whatever you deposit into an account, that is your principal. So the 1,000 is your principal. So into the P, I'm going to put my 1,000. E just stays in E. Now, your rate is your percent, but as a decimal. So we have to move that decimal twice to the left. So if I move the decimal twice to the left, right now it's behind the 4. So once to the left, add a 0, twice to the left. So my rate is 0.04, and I'm multiplying that with the T. And T is time, and my time is 10 years. Okay, and that will give me the amount I have in my account after 10 years. So pretty easy peasy. So in my calculator, I type the 1,000. Then I need the E. Okay, so above ln, which stands for natural log in blue, is e to the x. So we have to go second ln. And that pops up our e. And I'm raising that to the 0.04 times 10. And I hit enter, and that's going to be my answer. So we are going to have approximately $1,491.82. So money, we always round to the hundreds, just like when you pay money at a store or a restaurant. And that is answer choice A. Okay, next one. All right, so when you see log only once or natural log only once, you rewrite it in exponential form. So we have to know who the base is. So remember, when you're working with natural log, if you don't see the base, it's an E. And so we go around the world. So E raised to the third power equals x plus 2. So this is your process of solving when you have just one log or one natural log. Whereas if your variable is an exponent, you start off by taking the log of both sides to get the exponent to drop down. Okay, so that's your game plan when your variable is an exponent. Take the log of both sides. Same thing here. The variable was an exponent, so I took the log of both sides. so the exponent could drop down. But when you see just one natural log or one log, you put it in exponential form. You take the base, raise it to the power, and it equals the x plus 2. Okay, so to solve this equation, very simple. I get rid of addition of 2 by subtracting. So I'm going to subtract 2 from both sides. And so in my calculator, I just put e to the third power minus 2. So remember to pop up that e, I go second natural log. And I'm raising it to the third power. I need a right arrow to hop out of the exponent, and then minus 2. And this is my answer. So x is approximately, now we're going 4 decimal places again because this isn't money. So 18.0855. This 5 does not round up because we did not have a 5 or higher behind it. So that 5 stays a 5. And that is answer choice B, as in boy. Boy, howdy, that was easy. I hope you thought so too. Okay, so a minute ago, I was just telling you that when your when your variable is an exponent, you start off by taking the log of both sides so the exponent can drop. Well, this is the same thing here. Our variable's an exponent, so I need to take the log of both sides. The only thing is, since this is an e, my base is an e, instead of taking the common log, log, I'm taking the natural log of both sides. So I'm taking the natural log of the left side, e to the negative 9x, drop my symbol, and I'm taking the natural log of the right side, 6. So whenever your variable is an exponent, take the log of both sides, or in this case, take the natural log of both sides. Okay, once you do that, your exponent is allowed to drop down. So negative 9x drops down, and then behind it, you're left with natural log of e. Drop your symbol, and on the right side, you're left with natural log of 6. Okay, so in case you didn't know, it's time to know this. Natural log of e has a special value of 1. So every time you see the natural log of e, that has a value of 1. So what does that mean? That means you're taking negative 9x times 1. And negative 9x times 1 is just negative 9x. So it just like goes away. Yay. And then drop down natural log of 6. Okay, so then to get x by itself, I undo multiplication with division. So I'm going to divide both sides by negative 9. And then my x drops. Now, did you notice anything? I'm dividing by a negative. And when you divide by a negative, you've got to flip that sign. So we flip our inequality sign. And in the right-hand side, I put natural log of 6 divided by negative 9. Okay, so natural log is just this ln button to the left of the 4. So natural log. And 6, close the parenthesis, divide by negative 9. And this is my answer. So x is greater than or equal to negative 0.1991. That 0 rounds up because we have a 5 or higher behind it. And this is answer choice D, as in doggy. Okay, I'm going to stop the video here because this video has become kind of lengthy, and I will pick back up with number 7 on another video. Smiley face.